So in this video, I'm going to discuss a project that I've been working on for several years now. This is a small template engine that I've coded in Python. A little bit of a brief history. It originally started out as just a find and replace engine, just to update some system configuration files. But over the course of time, it wasn't powerful enough. And so I developed a simple engine, and somehow over several years it has become more and more complicated. The template engine itself is probably very bad code quality and still full of bugs, and there are definitely better ones out there, but it's my own little personal project. It served as a learning experience, and I'm actually using it in a couple of my other projects right now. The engine itself is real easy to use. There's basically 4 steps to using the engine. You create a loader object, you create the environment object, if I can spell right. Then you load a template from the environment and create a renderer and render it. So there are 2 types of loaders in this system. You have an unrestricted loader and you have a prefix loader. An unrestricted loader can load any file in the file system, whereas the prefix loader has a set of prefixes that map to paths, and it's searched in order, and basically you specify a path that you want to load and it tries to find it in one of those prefixes. Derived from the prefix loader is a search path loader, and I think a memory loader as well. A search path loader is really just a prefix loader where all the prefixes are blank, and the memory loader just stores things in memory. So since the first step is to create a loader, which is optional if you don't create a loader, it will just default to use an unrestricted loader. So actually the first step is to import everything that you need here. So but once you have your imports, then you create a loader, and then you can contain your paths for your prefixes here, for your templates. Now the loader, each loader works its own way. The template has a file name variable, which is the file it was loaded from, but it also has a little private variable, and some loaders might store information in there, whereas other loaders won't. For instance, the unrestricted loader only uses the file name, but the prefix loader stores the path of a template as a tuple in the template's private path, so any relative loads are relative to that tuple instead. Once a loader is created, you can create the environment and pass the loader to it. There are other variables you can pass. It supports built-in code objects, so you can specify whether you want to allow code or not, and a few other things. Importers to import variables or libraries. And then once the environment's done, you're basically ready to use a template. So to load a template, there's 2 ways to do this. You can load a template from a file, or you can load a template from text. To load a template from a file, you just call the environment load file. You specify a path to the template. Now, if a search path loader is used, this path will be a subpath of one of the search paths. If it's unrestricted, and that would be just the file system path. You can also call load text instead. Even if you're using a search path, it's just when you load a text, it's not cached, and it's treated as if it's loaded directly from the root. So anything that's loaded with load text should actually only, if it does any includes of nested templates, should only use absolute paths. If it uses a relative path, it's going to be relative to the root of a search path. And then finally, we create the renderer and render the output. There are 2 supported renderers right now. You have a string renderer, which renders everything into an internal string. There's also a stream renderer, which will render something to a file system like object using its write method. then you can render the template. And then once the data is rendered, you can access it. In the case of a string render, r.get will return the contents of that render. If there are any sections, you can get the sections from a render, which is one of the reasons I created this specific template engine. I needed a way where a single template could actually create multiple output files. And the way this can be done, this is actually application specific, of course, but if an application supports it, you can create a section within the template. And then everything within that section will be processed by the application. If you have this occurring multiple times, it can be used, if the application supports it, to create different files from one single input template and its whatever data set was passed to it. Earlier versions of the template engine didn't support good expression parsing. If you wanted to emit 1 plus 2, you would have to emit a function call. And more complicated expressions required nested calls to get anything emitted right. But a couple of months ago I made a change to the way the template engine worked, and so now it supports a more natural language. Instead of doing this, you would simply do this, or, and that will work because it now scans the region where the expression is expected at for certain things, and it tries to parse it down into a more natural expression tree. The way it works is actually based on an old expression evaluation engine I wrote many years ago. It also has an advantage now that it supports the concept of continuations. In the past, if I wanted to look up a index of a function call, I'd have to set a variable to the function call first, and then I could get the index. Like this. But now, since it supports something I call continuations, you can just do something like that. The way a continuation works is after all the unary and binary operators have been processed, and you get down to the very bottom, it'll try to parse a piece of the expression that it thinks should be there, and then if there's anything left, it'll treat that expression as the main expression and everything else as a continuation. So in this case here, we have a function call. It sees an identifier, it creates an identifier or a variable lookup expression, and then parses a continuation. The continuation sees this and treats it as a function call, so it creates a function call using this variable lookup expression, and then next it sees this continuation and it treats it as an item lookup using the function call, which in turn uses the variable lookup. There's a lot of different supported actions that can be done within the expression. It's fairly modular. I wanted to make it where adding a new action didn't require rewriting the entire parser code, so I've made it where the actions are actually looked up dynamically and then just registered, and then each action can change the which active handler exists. For example, an if action will parse first expression, and then it'll set the if handler as the active handler. Then anytime another tag gets processed, it checks to see if there's certain expected tags, and if not, it'll just use the default parser. There's a bunch of different actions. A break and continue tags are basically used for for loops to break out of a loop. Code tags allow you to embed Python code directly into a template, and the variables from the code can be returned, so you can create functions in it and then use those functions internally. For loops let you either iterate over items, or it also supports C++ style for loops. A hook function actually makes it where an application can register a hook, and then if a template calls that hook, then the application will execute a function at that point, receiving the render and scope object, and it can generate output dynamically or do whatever. And if there's no hook functions registered, it'll just be silently ignored. We can include other templates, we can import code libraries or variables from the application, and a few other things. But this is just something I've been working on for a long time, and I still got a lot of work to do on it to finish the code up and make it less buggy. There's still some bugs in it. Better commenting, better consistency between the code itself, because right now I still feel like, even though it works, and it works very good for my purposes, the code itself isn't really all that great, and it could be improved upon. Maybe some better tests to make sure it all works. Right now my tests basically consist of processing a bunch of input files and checking to make sure the output files are the expected values. But anyways, if anybody wants to check it out or use it for their own projects, it's open source, made available on GitHub here. It's licensed under an Apache style license, so if it's something that you like, good. Just be warned that it's probably still very buggy, and if you want to submit some ideas back, other ways of other actions that might be useful, then let me know. Other than that, have a great afternoon.